Okay, guys, I'm gonna quickly talk about quadratic function in the application of optimization. So basically, we're using a lot of quadratic function in solving problem, especially in solving optimization problem. And because we're living in the real world, we're only interested in any real solutions. So we need to always check our solution when we solve quadratic equation, that we know that we need to make sure our solution is reasonable. For example, if we're talking about length, the length has to be positive. We couldn't have -4 centimeters. That doesn't make sense because the length has to be physical, it has to be positive. And if we talk about number of people, that must be positive as well as an integer. Okay, so you can't have 95.5 people. That is wrong too. Okay, so we know that quadratic function is ax2 plus bx plus c. Okay, so we know it's either a happy phase or it's a sad phase. Depends on whether a above or a below 0. So we know that we have a axis of symmetry and also vertex. Okay, so normally if I'm interested in, say, minimum cost, I'm actually more interested in the smallest cost, which I'm actually focusing on this vertex. And if, say, for example, I'm interested in maximum area or volume, I'm generally interested in that point because that gives me the largest possible value of this quadratic equation. Okay, quadratic function, beg your pardon me. So when we talk about optimization, remember that we've learned completing the square technique. So we're going to use that quite intensively in understanding how we're going to maximum or minimum values. For example, I'll give you an example of a quadratic function. Okay, so if I ask you to do completing the square, which I think you guys should do it now on your book and then check your answer with my answer, okay? I would encourage you to pause the video now and then do it in your book and then resume after you finish and then check your answer with my answer. So I'm just gonna get that 2 out because when you do completing the square, you need to make sure whatever in front of x is 1. So y equals to 2, x plus 1, because that's x2 plus 2x plus 1. And then take 1 plus 4, y equals to 2, x plus 1 power 2 plus 3. If I open it, 2x plus 1 plus 6, because what I did is I times in. Okay, so now you know that the axis of symmetry is x equals -1. No problem, because I just need to get this part equal to 0 to get my axis of symmetry. And the vertex is -1 and 6. Okay, so this is pretty easy. Okay, so but coming to a generic form, we could also try to do it a completing square so that we know that we are actually using this value, which is actually the axis of symmetry. So if we do that, and which I also encourage you to pause the video, do it by yourself. Y equals to, get the a out, ba x plus. Okay, and then what you then need to do is exactly like what you, so this is equivalent of that. Okay, and then what you then need to do is you can this is exactly the same like that, and then what you then need to do is you could actually do it by half of the second one, the second term. Okay, so half of that number, and then do it by completing the square. So let's just do that now. So this is my second term. I'm just gonna do it. Half it. Because this part is gonna be Therefore, I have to take away. Okay, so you can see this part, which is equivalent as that part. Okay, so I can get my axis of symmetry. From here, I call this okay, so you can see at axis of symmetry, if A, and now that depends on my A value. If my A is above 0, it's gonna be a happy face, okay, and it's gonna be like this. And that is my axis of symmetry, and also the x-coordinate of my vertex is negative b onto A. And if A is below 0, then that is that sad face. So still axis of symmetry is negative b on A, okay? Right, so if you understand this, could we find the maximum or minimum turning point by graphing this function or on graphic calculator too, by using the G-solve button? So you can actually use the graphic calculator, which I have already given you instruction in the previous video, so you could have a look at that. I've listed some steps for you to follow, which I'm not going to go in detail with. You could actually read through yourself. And then in the next video, I'm just gonna do some example question, okay?